Hi, good evening and welcome in this my tutorial series on Matlab 2023. I hope in the first lecture you enjoy a lot of, and we try to cover the basic fundamentals about Matlab. Just was brief introduction, what we are going to cover, and there are several partitions of the Matlab also discussed. In today's session, what we are going to discuss or what we are going to cover, we will cover how we can plot 2D and 3D. Okay, because visualization is very important whenever you have any kind of data or you have any findings, results. Okay, whatever you have, and without visualization of the findings, it is very difficult to interpret. But when we have the graphs or plottings of our findings for our work, then it is very quite easy to interpret them graphical as well as numerical. So I think this session will be very helpful because there is 2D and 3D play a very important role in various type of findings whenever you will use. Along with the whenever you have solutions of differential equation, or you have optimization techniques, you have statistical analysis, machine learning, deep learning, data science, whatever you want. So this tool which we will discuss today will help you in many ways. Along with the all of you, many participants from you are registered. The link is given in the description of the channel. Okay, and we have also the list of all the tutorials. This series on Matlab will be at this time throughout the year on each Sunday, and each session will be over 2 hours. Some of the participants are regular in the various type of activities which was organized by MathTech Thinking Foundation. There are several type of training programs, workshops, faculty development programs, and many more. And there are some more participants who are new, and we got many requests from them. They are not able to access. But the most important thing is that the recording of this streaming will be available on this channel forever, and all these activities and the support is provided by MathTech Thinking Foundation, India. In this workshop or tutorial series, we have seen that more than 3,000 participants from different countries. These are about 40 or 45 or maybe greater than number of these countries. And I hope in this series, numerous mathematicians, scientists, students, engineers will join, and till the end of this year, I hope thousands of the people will be connected, and they will be benefited by using this platform, and all the sources are open. Anyone from any place can easily join and access all these things through this channel. And also I will mention here that if you have any question, please you can put your question in the chat box, and along with there is a feedback form which is also given. The link of the feedback form is given in the description of the channel. Okay, where this session is going to organize. Okay, so you must submit your questions, your feedback, so that according to that we can proceed, and this channel will be, I am sure, very helpful to all of you. Okay. So now you can see this is my Matlab. So what we are going to cover before starting the 2D and 3D plotting, you see if there are some participants are new, there are several partitions, and the major part where the cursor is moving, this is the command window. All the commands which we will execute can be stated at its place, or we can put the statement in the command window. And on the left hand side there is a current folder, on the right hand side workspace, and we have command history. So the most important part here is array operations, because when we have any small error while writing any kind of a function, or whenever any function involve any kind of array, in that case we have always some problem. So how we can operate them, or what type of operations we can do? First we need to clear all this, and then after we will start. Okay, so suppose here is very simple. X is equal to 0, then colon and 1 and up to 5. Okay, colon 5. So you can see here, I think a text which you can see are very clear to all of you, and there is no any kind of such a problem. Okay, all the things are very clear. Good evening all of you, all the participants, and I'm very happy to see in the chat box there are right now 46 are there, but I hope there will be more participants will join very soon. Okay, so this is one array. When I will enter, you can see one array has been generated, starts from 0 to 5, and this is the interval from 0 to 5. Okay, what is the meaning of this one? One is increment, one is increment, and this difference between any two consecutive point we have is equal to 1. You can choose any two consecutive point. Okay, so when you are dealing with array by using different type of operation, if you will do x plus x, this will return the addition of these two arrays. Okay, and this addition of two array is element by element. If you do the operation like x minus x, it's also fine. X minus x means 0, and all the element will be subtraction element by element, and it will return the answer. You can see 0, 0, 0 and 0. If we multiply x with x, okay, so this will when this sign is used for the product. You can see 2 product with 5 will be equal to 10, but in the case of array or matrix, we have to we must have their corresponding dimensions or same order of the matrix. Okay, so there are some rules which we have to follow, but here is one array, and the length of array when we are going to multiply must be equal if we have two arrays, and along with this product is element by element. See again, we have x equal to 0, 1, 2, 3, 4 and 5. So this product will be possible if we are using, see this point very carefully, x dot product sign x. So now you must see the above message, this one. It's saying that we have error while using the product sign. So see the last line of the above message. To perform element wise multiplication, we have to use this sign. Okay, and the sign is dot product. You can see if we are using the syntax like in this way, then this will help you. And okay, so when you are using this one, in that case there will be no error. Okay, so it is returning the result. I think it is very clear to all of you. You got it? Again, if we are doing like we have the answer, and what is the meaning of this one? We have element by element product. We are going to multiply x with x. Okay, we are going to multiply x with x. So this 0 and this 0, 0 into 0, 0, and this element is multiplied with this one. Third element is multiplied with the third element, and similarly last element 5 is multiplied with 5, which is equal to 25. So this type of product is known as element by element multiplication. Okay, so this is the element by element multiplication. So now if you have y is equal to, this is one more array, and this is starting from 0, and then we have 2 and up to 10, and when we will enter, you can see that the length of x array and y array both are equal, and now you can multiply x dot product y. Okay, and when I will enter, you can see we have the product of these two array. Okay, one is x and other is y. So this is the element by element product. 5 into 10 we have 50, and 4 into 8 we have 32. Also we can use for x exponent, we have x exponent 2, and when you will enter, this has again the same error. Okay, the meaning of x square is this one. The meaning of x square is this one. See carefully. So either you can do x dot product x, or you can do x square. So here is also the same notation to perform element wise matrix power. Okay, we have to use this notation. How we can do? Yes, we have to use at this place also dot product. Okay, we have to use x dot cap. So when we will use x dot cap, this will return the value. For exponent you can use any value, and you have to keep in mind while using. Okay, and this will return the corresponding result. Similarly, you can use this is 34. Okay, so the answer is very large. Okay, similarly, if you want to divide y by x, okay, we want to divide one array by another. So this is the division of y array with x array, and see we have this answer, and you can see here is nan. What is nan? Nan is not a number, and when this will occur, you can see in x array and in y array we are doing y upon x. Y is divided by x, so this element is divided by this one. 0 divided by 0, we have a number which is not defined, or in the form of indeterminate. So any number which is in the form of indeterminate form will return as nan. See, 0 divided by 0, okay, is nan. So that's why this first element is nan, and nan means not a number. And also there is pi. Pi is used for pi, and the value of pi we have is 3.1416. You must remember this point because these points will be very helpful when you will use these points for the plotting or for the different type of use will be there. Okay, and also you can see, okay, and x divided by y is also, we have this result. Okay, so all these values we have are 0.5, 0.5, 0.5 and 0.5. Because why this happen? You must compare these two arrays. One is x and other is y. All these values are twice of the x array. Okay, that's why we have these results. All these values are same, but 0.0 we have nan number. Okay. I and f is used for infinity. If you do infinity upon infinity, then this is also we have nan. Okay, you got it? If you have any question, you can put in the chat box and we will go ahead. Okay. I am observing the chat box also of YouTube. So if you will put any question in the chat box, I will try to justify your question. So now there is one more interesting thing which you must understand. See here, we can take like x is equal to 0.2, this one is 0.2, then we have 1. Okay, so this value 0.2 is the increment, and when you will enter, you can see we have the interval from 0 to 1, and these are the interval points which are equidistant. Okay, so when we use this statement, we will get the partition of the interval, and the length of each sub interval we have is equal. Sometimes we can use in this way, x is equal to, suppose I have 5, then minus 1 and 0. So here you can see this is in the decreasing order. So here minus 1 is decrement. Okay, so here we have 5 to 0. So sometimes we need to generate an array like in this way, and we can do easily by using this statement. Okay, so you can see how we can generate array. Now what we are doing, also in the very first session we discussed about the some statements as well as functions, inbuilt functions. So one of them is CLC is highly used. Okay. Now there is one more important part, line space. Line space is also highly used. You can see x is equal to, we have line space. For the line space we are using this statement, and we can use 0, 1 and 5. So when you will enter this statement, see, so we have the interval from 0 to 1. Okay, we have the interval from 0 to 1, and the number of points by using this number we have, you can see 1, 2, 3, 4 and 5. Okay, so this number represents the number of points on the line. Okay, so and the distance between each two consecutive point is also same at this place. You can easily observe this array. So we can use line space also, and as soon as you will use here 10, then we have in this way. Now, so as soon as you will increase the number, the size of the sub interval will decrease. Okay, so this line space will be also used for the plotting. Okay, now again we are using CLC. Okay, so when we will use the CLC, it will clear the command window. We are doing here very simple plot. X is equal to, I have 0. I am taking the interval from 0 to 2 pi. I have the interval from 0 to 2 pi. Okay, this is the interval from 0 to 2 pi, but I need the increments also. Okay, so the increment I am taking at this place pi upon 100. This is the increment, the middle term. This one is increment. So the use of a semicolon, I have already explained the use of a semicolon in the very first lecture. Also, we are using the semicolon here. Okay, so when I will enter after using semicolon, semicolon will suppress the statement, and the value of this array has been assigned to the X variable. Okay, so for the assignment, we are using equal sign in Matlab. We are choosing here very small, very simple function. Suppose it is y. Y is equal to, I am choosing here sin x, and again I am using here semicolon. Okay, so when I will enter, now we have two arrays. One is x, other is y, and the length of these two arrays is also equal. I will show you later. And now we are using very simple function to plot this graph. There are only two statements, and this one is the third statement, and third statement will plot the above graph of the above function. Okay, so this is very quite simple, x comma y. So only these three statements are required for 2D plotting for any kind of one function. And when I will enter, see, this is a very simple graph here. Okay, and this graph is from 0 to 2 pi. Okay, now we can do some more. We can do here grid on. We can do grid on. So when we will do grid on, what happen? Enter and see the graph. So when you will see the graph, you can see there are grids in this graph now. There are some horizontal parallels and vertical parallels with the equal distance. Okay, so these are the grids. So when you will use grid on, then we have some lines, and it can be easily observed from this place. Also, you can insert X label, Y label. All these things I am doing step by step, so that once you understand how we can do, you will use for 2D and 3D each type of plotting. But once you need to understand how the MATLAB work, and how we can use. Again, if you need to X label, this is also very quite simple. Sorry, this is X label. And here is X axis. Okay, I'm giving here the name X axis, enter. So what you will see in the image, you can see at the bottom of this image on the horizontal line, the label for the horizontal line we have is X axis. Okay, similarly for Y axis we have Y label. Okay, we have Y label, and what you will enter, you will have Y is equal to sine function. Okay, Y is equal to, you can give any name, but here we have the function which is sine x. Okay, or simply you can choose write here Y function or sine x, whatever, and you want to present. So when you will enter, you can see in the graph which we have plotted, we have sorry, I think there is some mistake. Okay, here is some mistake. The statements which we are inserting in the command window are very sensitive, and while you are entering the statement, see, these must be correct, otherwise this will return the error. As you can see here, the spelling of Y label is incorrect, that's why here is error. And now when you will enter, now the statement is correct and there is no error. Now check the image. Yes, you can see on the left hand side there is on the vertical line on the left, Y label is also there. And if you need to insert the title of the image, you can insert title also. You can insert the title. For the title, we have, this is first image, graph of sine function. Okay. Yes. And when you will enter, and you can see the title on the image is there. Now when you have image and all the things are justified, you can save this image. Along with that, I would like to explain one more thing. You must have the current directory. Okay, you must have current directory where you want to save your file, and you can choose if you have any folder you have created in desktop or any drive DE of your system, or you can see how you can select the directory. See, here is downward arrow sign. When you will click on it, you can go, you can choose the desktop. Okay, if you have created any folder on the desktop, you can choose that particular directory. Okay, so you just need to select that one, and this will become your current directory. You can see the current folder has been changed, and I have the current directory where I want to save all this file. So here is OneDrive. When I will click on it, and I have computing with Matlab. This is my current directory. I wanted to save all the files at this place, and okay, here is, okay, just 1 minute. here is some Matlab workshop. Here is Matlab coding. Yes, I want to save in this directory. Okay, and I have created one more folder. You can do this is live session. I save this file with the name of this one. This is a new folder has been created. Now I will open it, and all the things which we will do here automatically saved in this current folder. Okay, now this current folder is my current directory, and this is the path. This is the path. You can see that is place where the cursor is moving, and this is the current directory, which is the name of this current directory is live session. So this is image, and when I will save it, when I want to save this file, suppose the name I have to give the name of this image. This is figure. Sorry, this is figure 1. This is figure 1. Okay, and we need extension. If you will save this file directly, and extension you can see here is .fig. So .fig image will open only in the Matlab. You cannot export or you cannot use this image in Word document or other place. Just you can open this file in your Matlab. So what you have to, you can see when you will click here, there are several extensions are there. You can choose one of them according to your choice. JPEG is there. Then we have PCX is also there. AMF, .EPS, .BMP, and PNG. So mostly we are using .PNG extension or JPG extension. Sometimes we can use this extension .EPX when you are using LaTeX software. If you are preparing your scientific documentation, in that case you can use .EPS extension. You can use also PDF. PDF is also there. You can see PDF is also there. Okay, so it depends upon which type of extension is required for your work, for your document. So what I am doing here, I am saving the file with the name of JPG. Okay, and save it. So when you will come back at Matlab, you can see here the file which I save automatically in my current directory. Okay, so when you will go to the current directory, here is the folder which we have created, and when you will double click on it, and this is the figure 1 image, and when you will double click on it, okay, so this image will open and you can see this is the same image. Okay, so in this way you can create a 2D plot. If again you want to save the file with another extension, you can go to save as. Okay, click on save as. You can directly use here PDF. Okay, and enter. So you can see we have the file in the PDF format is also there. .pdf you can see, and again if you want to save this file in another extension, so you will do save as. You can use .eps. EPS extension is also there. Enter. So now you can see the files are automatically saving in our current folder, or you can say current directory. I think the current explanation is very helpful for all of you, and if you have any question, okay. Hello, okay, Jitendra is also there. Mr. Jitendra, you are always. Good evening, sir. Dr. Sundar Kumar Agarwal. Very good evening. Mr. India, Jitendra Singh. Is it possible to write inf in symbol? Yes, we can. You put your question is very correct, Mr. Jitendra Singh. You are asking about can we write pi in symbol? Yes, we can write pi in symbol, but when the session is come on symbolic mathematics, for that we have to use symbolic mathematics and we have to define first, and then after we can use. Okay, all these we will cover in the coming sessions. This will go throughout the year. Canada Solar and Academic, my graph did not show. Okay, your graph is not showing. See very carefully what happened. Where you are not able to see, okay. So when you are plotting the graph, sometimes what happen at the bottom, where the icon you can see, icon of the Matlab is appeared at the bottom on your system. Just move your cursor at that place. Okay. So when you will move your cursor at that place, you can see now there are two windows are there. One is for Matlab and other is for figure. So when you will click on the figure will open. Okay. So just you need to move your cursor at the bottom if sometimes the image is not showing you. Okay. And when you will click on the first tab, then Matlab is there. Again move the cursor to the Matlab icon at the bottom. Okay. So when you will click on the figure will appear. You can do in this way also. Thank you. I think you got it. Great. Now the thing is, I am using here CLC. I am using here CLC. And also come here. Yes. For the plotting, we were using X array and Y array. And you can see the dimension of X array and Y array both are equal. You can see the size. Size of X array is 1 by 201. There are 201 points in X array, and the same we have Y array. There are 201 points. The size of X and Y both must be equal. Only then this plot will plotted. And if you want to check these values, just you need to double click on it. When you will double click on it, see, these are the points you can see from till this one. Okay, there are 200. This is the last value, and last value is we have. You can extend all these. Sorry, 201. This is the last value, and you can check the value. This value is 6.2832. And similarly, you double click on Y. So these values are also there. Okay. And you can check all these corresponding values. You can also copy these values. Okay. So you can see when we give any input in the Matlab, this will generate always a matrix. And on the basis of these matrix, we operate. And that's why the name of Matlab is Matrix Laboratory. Now, control and plus n. Control plus n. What is the meaning of this control plus n? When you will press control and plus n. Okay. So I am doing here control and n. When you will this statement, when you will do this function control plus n, new file will open. This is the editor. You can write your script files here. You can write functions, you can write programs. You can write your script file. Okay, see, first I need to save this file, control S. So when I am pressing here, I will need to give here the name. I am using here is plotting. I am using here plotting. 2D. Okay. So the file will be saved in this name. And now I can write the same statements which we use for the suppose I have x is equal to 0, then pi by 100, then 2 pi. Okay, 2 pi, and this one. This will suppress the statement. And also we are using here CLC along with the clear. This will clear all the variables. Okay, and y is equal to I have sin x. Then I have plot. I have plot x comma y. Then we have x label, you can give the name of the label, whatever you need, x, and then we have y label, we give the name sin x. Okay, on the y label we have only sin x, the name of the function. And here grid on. So you can see a very beautiful program we have write for 2D plotting, and you can manipulate it. See, here is also the same thing. When you want, if you want to execute, just you need to press at this place. You need to press at this place. Okay. So when you will press at this place, we have the same graph at this place also. Okay, and also you can see that this script file is saved. Where is plotting? Yes, this is the script file. Okay, the script file is saved in the same directory. The importance of this script file is that you can use this script file in future anytime, but if you will do all these things on the command window, then these will be removed. Okay, once again I am explaining here how you can create this script file. See, there are two ways to create a script file. Either you can go to add this plus sign. On the top you can see there is plus sign. Okay, just 1 minute, I am showing. Okay, you can see here is plus sign. You can use this one. When you will press on it, new file open, and you need to save you can give any name according to your choice. My new file. I am giving the name my new file. And see, if you will give the space, this is incorrect way. Okay, don't use in this way. In the place of space, you will use underscore. If you want to give the space, you will use underscore. Otherwise, this file will be incorrect and will not save in your system. Yes. So when I will save this file, you can see this file exists in my current directory, in my current folder. Okay. You can do in this way. Vani, I think you got it. Yes. Okay. Please to open the APS file. Do I need to download? Yes. Cecilia Sambo, if you want to save the, if you want to open this file, you need to download to open this image with the extension .aps. You need to download, and in the case of LaTeX, you can directly use this extension without installing software. Okay, LaTeX will consider this extension automatically, but if you want to open, then you need to download this software, and only then you can open directly. Otherwise, you can open by using LaTeX, and this file will open there. Okay, great. So now in this way you can easily open. So here what you can see, if I do here, I have one more function, cosine x. I am choosing here cosine x. Okay, so if I will run this file, you can see there is error message. There is error message, and error is in line number 3. See this statement. Error is in line number 3. So you can see this is the line number 3. In this line, there is an error. Why? Because we have, this is one array, this is one array, and the y function is combination of two functions, sine and cosine. Okay, so the problem is that sine function create one array, cosine function create another array, and we are going to multiply at this place, and this will be possible product of two arrays when we will use at this place dot sign also. Now this statement is correct, and when you will execute, we have the graph of the function which we choose at this place, sin x and cosine x, the product of sine and cosine. Okay, this is the product of two functions, sine and cosine. Okay, and you can here, the title of this function is now, title of this function we have is, yes, you can say Claudine Abedia asking it is vector. Yes, you can say vector and array, no problem. This is vector. Okay, so the thing is that here is also two functions, and we can change the title here, sine and cosine. So sorry, this is the function, and you can insert here title also, title. Okay, title we have is new function, or you can give the 2D plotting. 2D plotting. Okay, and see, yes, we have x label is there on the horizontal line, y label is also there on the vertical line, and at the top there is title is also there. Okay, and you can save this file. Now we are doing some more operations. Okay, and next we have, if we have multiple lines, if we have multiple lines, and I am doing here plot of multiple lines, okay, plot of multiple lines, and I am choosing here the interval is from -2 pi to 2 pi, okay. X is equal to, I have, we can use line space also, linspace, okay, we are using here linspace from -pi to pi, -2 pi to pi, okay, -2 pi to 2 pi. We are choosing here -2 pi to 2 pi. This is the line space. And then we have two functions. One is y1. Y1 is equal to, I have sin x. Okay, y1 is equal to sin x. And then after we have y2. Y2 is equal to, I have cosine x. We have two functions. We have two functions, okay. And how we can plot? This is figure 1. Figure 1, okay. Plot. If you are going to plot two functions, so first we will plot y1. And for the plot of y1, we have x input, then y1, okay, then comma x y2. So in this way, you can plot these two graphs in the same image, x y1, x comma y1, comma x comma y2. So for both function, we have same domain. X is the argument for y1 and y2, okay. So in this way we can plot, and when you will execute these sequence of statements, we have a graph of the two functions. These are two functions, you can see. One is of sine function and other is of cosine function. But the problem is that how we can recognize which function is for which graph is of sine function and which one for the sine function, cosine function. For that one, we can use here legend. We can use here legend. And how you can use? We have y1. Y1 is first function, and then comma. We have y2 is second function. So when you will execute again the same, you can see in the image we have legend. You can see the blue line, y1 is blue. So blue graph you can see is for y1 function, and the red function is for y2. So in this way we can use legend, and you can edit this legend, you can fix anywhere when okay. You got it? Please let me know you got it. Everything is fine. If you have any question, please always feel free to submit your question. Yes, great. Thank you. Thank you for responding. Now, we are doing some more advanced. If you have any matrix, can you plot any matrix? See, I did not use here CLC and clear. Okay, PLC and clear. Okay. Yes. Suppose I have y is equal to magic 4. So this will return a matrix of 4 by 4 order. This is the matrix of 4 by 4 order. Okay. In the command window, when you will use magic 4, we have the matrix of 4 by 4 order. And if you are using magic 5, okay, we have a matrix of 5 by 4 order, and there are some properties of this matrix. The addition of first row and second row, also first column, second column, and some of the diagonal, okay, are always equal. This is the property of this magic. So if you want to plot this y matrix, just you need to use this statement, plot y, and this will return us the graph of this above matrix. You can do. Okay, so you can see here the plot of matrix, and this is very quite simple. You got it? Sometimes we can specify the statements. Okay, I have chosen one more statement. I am taking here one more file. See here is Control S, and I want to save this file specific image. Okay, and save it. So here I have x is equal to, I am choosing from 0 to pi by 100. Then I have 2 pi. This is the interval. Okay, and suppress it by using this statement. And CLC clear. Okay. Here is also y1 function is, we have y1 is equal to sine x, and we have y2 function, y2 is equal to, I have sine x minus 0.025, sorry, 0. This is 0.25. Okay, and suppress it. Then we have y3 is also new function, which is a sine, and this is x minus 0.5. Okay, or you can use 0.5, like in this way. So we have y1, y2 and y3, these three functions, and then we have the figure and plot these figures. I have x comma y1, okay, then x comma y2, then x comma y3. Okay, so when you will execute this statement, you have 3 graphs. Okay, you have 3 graphs. If you want to customize, you can do. For second image, we are using here marker. We are changing the line. We are changing the line style. Okay, and for the third one, we are using this one. So when you will use in this way, you can change the style of the line, and when you will execute, you can see the style of the line has been changed for the 3 lines. Okay, and also you can use here legend as we use in the previous one. We can use all these three statements in the same figure, copy and paste, but here is legend are three functions, and third one we need to also insert here y3. This is y3. Okay, and now you can see legend is also there. Okay, if you want to use grid on, you can do at the end grid on also. You have very beautiful graph. Sorry, grid on. Okay, yes, you have very beautiful graph and you can save it. Now if sometimes we need to change the color or line style, we can do. If you want to change the color of the first one, how you can do? You can do like comma and G. G is used for green color. G is used for green color. Okay, and then if you want to change the color of this one also, B is used for blue, and also you can use this marker. There are different type of markers in the Matlab. I will show you all these. And for this one, third graph, we are using here T and this one. See what happened. Yeah, you can see the graph in this form. Okay, so these we are using here markers. The circles and stars are the markers. Okay, and line styles also we can change according to our choice. Markers in Matlab, you can find markers. Okay, so when you will find a marker in the Matlab, you will get the list of all the markers. Here are the markers. Okay, you can find in the Matlab, and there are several markers. Just 1 minute. Okay. Line marker. Line marker. Line plots. Yes, you can find here markers are also there. Okay, and when you go to down, yes, there are different styles are there, and ways how you can use markers. You can find more examples. Okay, in the Matlab, various examples are there. You can see at its place how you can add the markers. This is the marker. Okay, and also if you want to specify, you can do. If you want to control placement, you can do also the control the placements by using marker indices. See, you can use this code directly in your Matlab. You can use this code directly in the Matlab. Yes. So here is the code. X is the line space from 0 to 10, the interval, and there are 1000 points. This is the y function, and here you can see plot xy. This is the marker, and marker indices 1 to 10 up to length y. Okay, you can customize the markers, and when you will run, you have the graph. Sorry. Sorry. Yes, you need to enter here. So when you will enter, you have this graph. Okay, so many things are there in the MATLAB for 2D. Now what we are doing, we are going to discuss here. There are various type of 2D plotting. Okay. MATLAB coding. Yes. Close all this file. I am closing all this file. I have prepared some script file, and we left only 1 hour, and we want to cover 2D and 3D both. So here you can find, sorry. Okay. Yes. We have contour plot. If you have any complex function and you want to plot, you can do. So here is the displaying contours in polar coordinate, and you can see here is, see the first statement. See the first statement, what is there? Theta and R. Okay. This will generate Meshgrid. Meshgrid is very important, and how it will work I will explain. So theta is varies from, you can see, 0 to 360, and we convert in radians by multiplying pi upon 180. Okay, we convert in degrees, sorry. And the value of R we have is from 0 to 1. This is the interval of R. The length of R is, we have 1, radius is 1, from 0 to 1. And the increment for the same to generate Meshgrid we have is 0.05, and here is this one. So this is the theta, and this is the value of R. And what we are doing, we are converting this one into polar coordinate to Cartesian. So we are using this function to convert polar coordinate into Cartesian form. Okay, so we have new variables x and y. The value will be saved in this one, and theta r is also there. So these polar coordinates will convert into Cartesian, and we are using here pole to cart function to convert polar coordinate into Cartesian. This is the z variable, which is equal to x plus iota y. So if you want to define any complex variable, then you can easily do in the MATLAB by using, note this point very carefully, x plus iota y. Okay, in MATLAB, sorry, I will be equal to 0 plus iota. Okay, I is equal to 0 plus iota, and also j is used for iota. Okay, so I and j both are equal to root minus 1, square root of minus 1. Okay, so it's depend upon, you can use either I or you can use j, both are same. Now you can see here we have very simple function, which is f is equal to z raised to power 4 minus 1 upon then its fourth root, okay, and we want to generate its surface. So x is there, y is there, and absolute value of f. To generate, we need absolute value of f. Okay, so this is the f function. Okay, so rest we have all these things are same, and this is the this is used for contour. Okay, this is used for contour. For contour, we have a contour function, and you can customize. Axes are equal, x label is there, y label is there. Okay, and you can fix the font size also. Okay, font size is also we fixed at this place. You can see, and similarly at this place, hold on and hold off. See, hold on and hold off are used for multiple images. Okay, we want to use this value here also. See, when we run this code, we have two images. Okay, so this is the surface of the function which we choose at this place, and in the second image you can see these are the contours. These are the contours on real axis and imaginary axis, horizontal and vertical line. Okay, you can insert here also box on. You can do here box on. Okay. See, now there is box. Now see, there is box and looks more beautiful image. Okay, and also you can rotate this image in any direction, and you can fix according to your choice. Sometimes we need to change its position according to our requirement. Okay, you can rotate in any direction. You can rotate the at 360 degree. Okay, in this direction and in this direction also. So in this direction now we have value of f become 0. This is now in the plane of in the complex plane. Okay, and the okay, so these are the contours. ezplot, you can directly use this function. Okay, so you can see here we have sin x by x, and interval is -4 to 4 pi to 4 pi, and this is the title. Only one statement is required. This statement will plot the graph for sin x by x in the interval -4 pi to 4 pi. See, here is the graph of the same function. Title is there. Okay, similarly we have contours, compass. Okay, we have discussed this one. Okay, ezplot is also discussed. Yes, sometimes we have this also we discuss. Plotty is very interesting. You can see Here is x, then we have y and y2. Okay, so you can see this is the plotty graph. And what is plotty graph and why we need? See, when you will plot and see this image is called as a plotty graph. You can see the interval is from 0 to 20. Okay, 0 to 20. And on the left hand side, y varies from minus 200 to 200. Minimum value is minus 200 and upper value is 200. And for that of the another function, the minimum value is minus 0.8 is the minimum and the maximum value is 0.8. So if we are using only plot, then see what happen. The one graph is only just seems to be horizontal line, but actually this is not the horizontal straight line. What we have to do, we have to minimize the interval. Okay, so to see the difference between these two, we need a plotty graph. So plotty graph will automatically solve our problem. Okay, so when you will use plotty and see the difference between these two, so that's why we are using plotty graph to compare the two graphs in the same image. I think you got it. If you have any question, you can put in the chat box. We will try to please save this plot in PDF file. Yeah, I have, Surendraji, I have already saved the file in PDF. Yes, all this also you can do. All these graphs which we are discussing now, we can save in PDF format or other format, and as well you can see the folder here. This image is in the PDF format. In the very beginning, sorry, refresh. Okay, and something went wrong. This format is in PDF. We can open with the add operator. I think this file is not correctly saved. Okay, this file is not correctly saved, but we can do. No issue. Yes. So we have multiple graph. This also has been discussed. Okay. And trade subplot, spiral. Yes, here is some spiral also. T is the time limit, this is the S value, spiral rate, and Y is the function which is exponential minus ST. Okay, and this is the stems, y and MSYT, hold on, and this is the plot, real Y and MSY, T and R. And when you will run this code, see, this is the spiral. Jyotsna, thank you, Jyotsna, from Career College, Bhopal. Okay. So now there are many ways to represent, and you can find the list of all 2D plotting in Matlab. What you will do, you will search here plot. Okay, and when you will click, you can find all the syntax for different type of graphs in the Matlab, and here are the syntax are also there. Okay, many things are there. You can find everything. Sometimes if you need two plots in the same image, you can do. If you need two plots in the same image, you can do. And here are the syntax for the same. We have this is the syntax I am using from this place. See, Control S, multi images. Okay, so you can see the text are now visible to all of you, are very clear. Okay, so here this is the line space, this is the y1 function which is 5x, then we have y2 function which is 15x. Okay, and this is the tiled layout we assigned here, this one. Okay, then we have ax1 next title, plot, and title of because now we have two images. Okay, and layout is this is the dimension, so there will be 2 rows and 1 column. There will be 2 rows and 2 column, means one image will be on the top and second image will be below. So this is the code for the top plot. So ax1 is next title and the plot ax1 xy1. So ax1 will be the plot of first one, is used for first image. So this is the arguments which we pass here, and title will also pass ax1 top plot because we are using here next title. Okay, for the first image, and similarly we will use for the second image. Here is the y label, title is also there, you can see, and this is the code for bottom image, below image. Okay, ax2 is used for the second image, which will be equal to next title, and plot of the second image we are using here ax2 because for the second one, and this is the these are the argument x and y2. Similarly we have for the title and y label. So when we will execute this statement, you will see that there are two images. There are two images, one on the top and second is at the bottom in the same image. Okay, and this is the meaning of 2 1. 2 means 2 rows and 1 column. Okay, if you are using like in this way, then what happen? See, so there are 2 images on the top and 2 will be below. You can insert this will the matrix of images 2 by 2 order. Okay, 2 rows and 2 column. So you have to need some more images. I am copying from this place and paste at this place and see what happen. Yeah, now you can see these are the images 2 by 2 order. Okay, so in this way you can do. If I am using here is 4, here is 4 and at this place is 1. See what happened. There are 4 images in one column. There are 4 images in one column. So in this way, sometimes we need multiple images in the single for their comparison, and we can do in this way. Okay. So now we will discuss about 3D plotting, and we left only 30 minutes. So the script for all this I have already prepared. Just there is a little bit difference between the 2D plotting and 3D plotting, and I hope this will be very helpful for all of you. Just you need to understand the syntax, and once you will understand the syntax for 2D, you can got all these values for 3D plotting also. Come here, yes, I have the interval, just come back, and this is the current directory for 3D plotting, and I will take very less time for this. If you have any question, you can put in the chat box of the live streaming, and I will try to justify you if I got your question. Some participants are asking about the script file. Yeah, I know the codes which we are preparing and the lectures which we are delivering, and sometimes if you have any problems how you can get more help, I let you know very soon. I hope hopefully in the coming Sunday we are developing an app for the foundation, and because this is a live streaming lecture and we are not able to share your this content through your email address, only because we have observed that many times our mail sent in your spam box. So in that case you are not able to get these emails, and sometimes while entering your email address there is error. Right now there are more than 1000 participants registered through the Google form. Okay, and there are 4 WhatsApp group also. In one WhatsApp group there are 1025 participants. 2 groups are full, third group is a half, and 4th group there are about 40 to 60 participants. So overall, if we combine all these 4 groups, we have about 3000 participants who registered or who are interested for this series. But the thing is, many times you are not able to get all these things on the WhatsApp or through the email address. So we are trying to reach to everyone. So the solution we have is we are working on to develop a mobile app for this foundation, and many things will be there. The content which we will present will be available on app, and the most important thing is you can use all these things anytime, whenever you are feel free. Okay, there will be short courses will be also there, which you can access them, and according to your interest you can check. In the coming session we will share you all this information from where you can download this app. Okay, so don't worry, just wait for only 1 week, and I'm sure we will come with the new solution, and this will help you in many ways. So now we will discuss about 3D plotting, and we have already prepared here script files, and all these script file will help you. You can see that Meshgrid we used in the previous image. Okay, so what is Meshgrid? Here x is from 0 to 10 and y is from 0 to 8. So when we will execute this script file, okay, also I'm using CLC and clear. So when I will execute this statement, see what happened. See what happened. You have to open this one. Okay, you have to open. So there is x and y, and you can see the size of x and y both are equal. So that's why we are using Meshgrid. Okay, this will work if we are going to plot 3D. The dimension of x and y both must be equal. Only then we can plot 3D, because dimensions of each must be same. So here the interval are different, but Meshgrid equalize the matrix. When you will double click on it and double click on y, see. So the value of x from 0 to 8. The value of is from 0 to 8. Okay, and just it converting the maintaining the order of the matrix, and the order of matrix is 5 by 11. The order of the matrix is 5 by 11. You can see this is the matrix. And similarly, come here for the x1, x variable. So x is varies from 0 to 10. You can see, but the order of this matrix is also 5 by 11. Okay, so the order of these two both matrices we have same. That's why we are using Meshgrid. Now we have multiple graphs are there, and I will take very less time to explain all these. Yes, so we are starting from this one. This is the Meshgrid, and the interval is from -2 to 2, and then we are choosing here z function. Z is equal to, we have x dot product exponential, and also you can see here also we are using dot. Here is also we are using dot. Okay, so because this is one array, this is one array, this is also array. Okay, that's why. And plot 3, we have different type of functions for the plot. See here, when you will open this new command, come to this new window, and here is 3D plot. Okay, polar coordinate surface. Yeah, yes, you can see here are various type of functions are there for 3D plotting. This is the complete list. You can see here is complete list. Okay, and you can make increase the font size. How you can do? Control and +1. Yes, yes. So you can see these are the functions. Surface will plot the surface plot. This will plot a contour plot under the surface. Surface primitive. Okay, surface 1, surface plot with the color map you can use. Okay, we will use some of them, some of this. So just to see here, we are using plot 3, and yes, so this is the plot 3, and you can easily rotate in any direction. These are the lines, curves. Okay, these are just curves. Here you can use also, just 1 minute, what happened? Yeah, okay, X label, Y label are missing. You can insert X label and Y label also. Here is also one more example. You can see t functions are in parametric form. Okay, so the value of parameter is pi upon 32 20 pi. The value of t varies from pi upon 32 20 pi, and this is the increment in the t. And we are using plot3 function. Plot3 is used for a three-dimensional graph. This is the value of x. X is equal to, we have t cosine t, and y is equal to, we have t sine t, and z equal to, we have log t. Okay, so these are the equations of function in parametric. So when you will play, yes, so this is the graph in 3D, and you can see the dimensions, and you can rotate, you can select in any direction, you can insert here x label, y label, title, whatever you need for you. Okay, similarly you can get here in the new one. Yes, so here is surface plotting. Here is surface plotting. We are using here surface. So Meshgrid is there, and in length of interval -2 to 2, and increment is 0 to 0.1. Firstly, I am choosing here 5. Also, this is the argument x, then y, and this is the function. Function we have is, this is the value of z. You can use in this way also. You can use in this way also. Z is equal to, okay, so there is no difference. Depends upon you how you want to use. Then we have edge color none, and box on. Then grid also on. Okay, and if you want to insert x label, y label, we can do. Yes, so when you will run this statement, you can see this is the image. Okay, this is the image, and you can rotate in any direction. Okay, so edge color none. If you will remove this statement, now see the difference. Now you can see edges are there, edges of the curve you can see in the image. Okay, so this is the difference. And also there is one more thing. I am doing here Control Z. I am doing here Control Z, and also here is 0.1. Here is also 0.1. And again, when I will run, see, this is the surface. Okay, surface generated by this function only. If I am using here surface C, I am using here surface C, and when I will run this program again, you can see the surface along with the contours in XY plane. You can see surface as well as the contours are there. You can see in the image. Okay, so by using only this one, we can do numerous experiments. You can use this one also. Okay, we are using this one. What I will do, I just replace this function. Okay, and run. Sorry, edge color. Oh, I have to remove edge color. Okay. Yes, we have this one. Okay, you got it? And also we have some more functions, mesh C, mesh. If you are using mesh, then here is surface and here is only mesh, then the graph is in this form. Okay, so only the mesh is there. Curves are intersecting each other, but there are holes are there in the form of a square. You can observe this is one of the example of mesh. This is mesh plot, you can see. See this one. Okay, so this is the mesh plot, you can see. Then we have, if you are using mesh along with the C, yes, so we have the mesh plot, along with we have the contours at the bottom, you can see. If you want to use, okay, surface C, the ribbon is there, ribbon. Okay, see what happened if we are using ribbon. Sorry, ribbon is used for 2D graph, 2D plotting. We are not able to use here ribbon. Ribbon is used for 2D. And contour 3 is used for C contour 3. We can use contour 3. And run this one. So these are the contours in 3D. Okay. These are the contours in 3D. You can easily observe all these curves and lines. These are in 3D. Got it? Are you getting? Any question, please? I will try to reply your question if you put your question in the chat box. Okay. So I present here several examples, and then you can come here. Here is very simple. You can see that we are using here sims. Sim is used for symbolic variable, and if you want to use EZ surface, and you can see that we are not using any kind of mesh, just this function is sufficient. P. This is the EZ surface. This is the EZ surface. You can see, you can rotate, you can observe, you can interpret. Why this type of images are required? Because images which are sending from the space are appeared like in this form. Okay, so when we interpret this type of images, if you have this type of image, then you can see what happened. The dark color will be in the bottom and the yellow part will be at the top. See, yes. Okay, so this is the importance of this type of images when for the interpretation. Okay, and also you can see the contours are there. If you will use here one more statement, box on, then this will appear like in this way. Yes, box on. Now there is box. Okay, box on. Then if you want to remove only C, now there will be no contour. Yes, now you can see in this image there is no contour. C is mostly used for contours. I think you got it. And here is also one more example. T is parameter from 0 to 10 pi, and plot sin t, cosine t, and t. This is the value of x variable. Then we have y variable. Then we have z variable. Grids are on, and x is square. Means the dimensions of x and y both will be equal. Okay. See. So you can see the dimensions of x and y both are equal. You can see this image. Okay. Here is also a very simple example, and the same I think we use. This is the surface plot. This is the surface plot. We have to minimize the increment. Yes, now see. We have plot this graph earlier. This also happened. Yes, here are sems x, y, z, t. Okay, these are the variables. X is equal to, we have sems is used for symbolic variable. Keep in mind, sems is used for symbolic variable. Okay. So this is the x variable. Then y, x in parametric form. Y is also there. Z is also this one. And we are using here ezplot 3. Ezplot 3. Okay. X, Y, and Z. So you can see that we did not define any interval for t. This will ezplot 3. What will do? This will manage all these dimensions automatically. So when you will execute this statement, you can see that we have this image. The function was in the parametric form. Okay. So these you can also insert here grid on, box on. Okay. Now see. Yes. Grids are there and box is there. Okay. So X label, Y label, Z label, and title, all these things are appeared automatically when you are using only ezplot 3. We are not defining here the X label, Y label, Z label, okay, and the title. All these appeared in this image automatically when you will use ezplot. Dimensions are automatically managed. Okay. You got it? You got it? Salahuddin. Okay. Johan Adoga. This is beautiful, Professor. Thank you. Okay. Nice comments are there. Thank you very much. If you are enjoying my lecture. So these are the content which are presented, and I hope all these are sufficient for you. Okay. So I am closing all these. Yes. So if you have any more like 2D, 3D, if you will come here, images, printing, yes, polar plots. Polar plot is also there. Okay. And here are all these are available in the documentation file. How you can get this file in your MATLAB? What you will do? Just you can see on the right top, just you need to insert here plot and then enter. Okay, so this file will open and you will get everything here. Everything is there. So click on it. You can get the syntax for 2D. Okay, and you can get the syntax for 3D plotting also. You can get the line plot. Examples are there. Various examples are there. Okay, from this place the topics will start. Just you need to click on it. You get several examples are there. Okay, you can get several examples are there. How you can insert this? These are the statement. You can easily use at this place. After login your account, you can directly use them online mode. Okay, and here are the labels. You can insert label of the axis and title. Then you can plot. How you can plot multiple images. These are the syntax. Okay, and this is the use of hold on and hold off. Okay, so this code will plot the first image, but for the same dimension, for the same domain, we want to plot one more image, y2. Okay, for that purpose we have to use hold on and hold off. Okay, here is y2 and this is the image, second image. So hold on and hold off, what will do? This image will plotted along with this one. So in this way we can use hold on and hold off statements. You can get more information here. You can, various examples are there. Here is one more Loglog. Loglog plot is also very important, and you can get more information about the Loglog. Yes, for that purpose we have to use log space. Why? Sometimes we have the data is, the values are very high. Okay, define x as a vector 50 logarithm of 10 raised to power minus 1, 10 raised to power 2. Okay, so we will use here log space minus 1 to 2. So the interval is for this one, 10 raised to power minus 1 to 10 raised to power 2, and this space is inserted by using log space. Then we have the function 2 raised to power x. Y is equal to 2 raised to power x. We are using here log function. Okay, log xy, grid are on. So the plot of this will be, you can check in the here. Yes, this is the graph log, and you can see on the left bottom 10 raised to power minus 1, on the right bottom 10 raised to power 2. Okay, and this is the required image. If you want to get more information, more graphs, yes, various examples are there. You can go through this page. Okay, and this page will also open online. You can get more information about this. Very informative and very helpful for your use. Okay, So if you are using Matlab, I don't know which version you have. Okay, so what is your requirement? How we can help you more and more? Okay, so if you will submit your prompts, we will cover your prompts in the coming sessions, and this will help in many ways. Okay, so now it is time to close the session, and how can I get the recording of these tutorials? Actually, the thing is, you are asking how you can get the recordings. These recordings will be available on YouTube channel. Just 1 minute, I would like to show you how you can get. Yes, see how you can get these recordings. You need to open YouTube. Okay, you can open YouTube and then check here MathTech Thinking Foundation. Okay, MathTech Thinking Foundation, and when you will click, this is the foundation YouTube channel. Okay, and here is playlist. This is the playlist. So when you will go to this playlist, this is the playlist for Matlab tutorial series 2023. All the playlists are available there. So when you will view the full list, so all the lectures will be available in this playlist. Okay, so lecture 1 is over, lecture 2 is now live. Okay, and this will be available permanently. We will not remove all these lectures. All these lectures will be available permanently. You can watch again and again. You can share with your students. You can share with your colleagues, friends. Okay, because if you think that these lectures are important for your use, for your colleagues, for your students also, you can provide them, and I hope this will be help you in many ways. Okay, so everything will be available at this channel. This is the foundation channel, and once the recording will be available there, you can access anytime, and all the events which we organized previously are available. All those lectures which was on the live streaming are available, and we will not remove all these live streaming lectures. Also, yes, so I think you got your answer. Now it is time to close this session. Thank you very much to join this live session, and this will be throughout the year. We will cover a new interesting topic. So wait for coming Sunday. Thank you very much. Good night.